Hello, everyone. Thanks for tuning in to our After Dinner Min series titled Behind the Code. On the show, we welcome Art Blocks artists to share a deeper look into their project's creative coding and process. Today, we welcome ixnayokay, who joins us to speak about his project implications. At the end of the show, we'll open the floor to questions that have been asked on the live YouTube page or Discord. Welcome, Ixnay. How are you doing?
Doing well. How are you?
I am excellent. I'll let you take it from here.
All right. Thank you so much. So this evening we'll be talking about how implications was built, some of the techniques that were used, some bits of trivia, and the code along the way. We'll have some time to play with the code a little bit, mess with some things, see what it does. I'll start out by talking about the higher level structure of the application, and then I'll go into more detail about how the main algorithm works. So this is my second vanilla JavaScript project I've done for Art Blocks. I've been working on refining a framework in pure JavaScript to leave room for an additional library because I want to play with sound at some point. So I figure if I can do all the graphics with vanilla JavaScript, at some point I can add some sound because I'm not going to do that by hand. So vanilla.js, go through some of the parts of that. So over here on the left, I've got my code window. This is some pretty generic functionality for generating random numbers, generating random integers, random booleans, that sort of stuff. Pretty cut and dry, nothing too exciting there. Core is where things start to get a little bit more interesting. So this file, I had a similar file in Zoologic. This is most of my framework code that's responsible for drawing the animation on the screen, making sure it's the right size, making sure it looks good on different devices, managing the frame rate, those sorts of things. You can see here I've got some custom code that's particular to implications. So I'll walk through some of that. First thing we see up here is the different detail levels for the application. So if you've seen like a mega detail level with big blocky outputs, or a Pico that's super detailed, this is the number of blocks that are in those and their names. I have a variety of helpful things here. Found a bug at some point where I needed to know if the user was using Safari. So got a Boolean for that. Need to know if the user's on a headless browser for capturing snapshots. Need to know if they're on mobile. A whole lot of variables in here that are fairly generic. One I'll call out here that's kind of interesting is the help content variable. This is just a whole bunch of HTML. You might have noticed in Zoologic or implications, there's an HTML menu that you can open. So this is the HTML that drives that. Heading down a little further, I'm just going to give a disclaimer here. I'm going to go into, at a pretty high level, all the code, and I'll get more specific about some parts. But I very much code sort of stream of consciousness. I do software engineering for my day job, and so I find it pretty freeing to sort of just code what I'm thinking, not worry too much about making it neat or clean, and just sort of iterate, and almost create my own little maze as I'm building an app over the course of a few months. So you'll notice some of the variable names aren't the most descriptive, but there's the disclaimer. So this block of code here, we're starting with, you may have noticed there are different blur levels that you'll see on implications. So some of them will be very dreamy, some of them will be very crisp. Those are all controlled by this. So we've got a couple of variables that determine the transparency that things are drawn with, and a couple of variables that determine in between each frame, like how much of it is wiped away. So if we wipe it away all away each frame, you get a whole new drawing. And if you don't, then some colors from the previous frame bleed through, kind of like we're seeing here. So these were figured out by a lot of trial and error. I use a lot of trial and error in general when I'm trying to refine things. It's the case for the automata that are used. It's the case for the colors. and I'll talk a little bit more in detail about that. But a technique I'll often use is I'll have some sort of, I call it scaffolding code, or I'll write some sort of code that it doesn't make it into the final application. It's just code that's used for the development process. So I don't have the scaffolding code here for this anymore, but I basically tried a bunch of different transparency effects to figure out, which styles I like the best. I kept some of those. Let's see, let's scroll through here. I've got a lot of interactive controls and implications, like the ability to pause here. So the function that controls that is this toggle pause function. You'll see a lot of these sort of functions that are just handlers for events. I've got one here for toggling perfect pixel mode, which if I turn that on or off, kind of cool. Like, probably won't get too into the weeds of exactly how the math works for this, but in a nutshell, what this feature does is it resizes the canvas to be drawn in such a way that maybe this will be better to illustrate. Let me see if I can lock in this resolution here real quick. Pick a particular hash here. That one will do. Forgive me if I'm skipping around. I'm just gonna pop over to my animation real quick. Yeah, that'll do it. So here I set the detail level to this to like the Blanc's detail level. So you can see that this is a much blockier output. Let me switch back to my core here. Right, so toggle perfect pixel. If I turn this on again, you'll see that it doesn't go out quite to the edge of my window. And what this is doing is it's saying, out of all the pixels I have in this window to work with, how big can I make these individual squares that are part of the animation so that each of them is a uniform number of pixels. So each of them is exactly the same, and each of them fits into an integer number of pixels on the user's screen. So this feature doesn't work the same way on every computer. It is customized to each user's resolution, which was something new and experimental. But that's what that perfect pixel mode is. Toggling pause, so you can pause the pattern changes. Kind of just scrolling past some of the stuff that's a little more generic. Here's a good example of a variable that's a little more esoteric. Super Dreamy. Super Dreamy is a feature that is not exposed. There are quite a few of these. If I back up for a second here, this slow and steady index actually determines what the blur level is. So there are 7 possible options, from very blurry to very crisp. Let's get back to where I was. So what the Super Dreamy mode does is it adds some additional like blur and sort of dreaminess, which is what it's named for, but only at the 2 lowest blur levels. So, well, the 2 highest blur levels. So that would be like your high A and high B blur level that you see, as well as I believe medium B and C are the next 2 that get this effect. So let's keep an eye out for Super Dreamy. We'll see that again. We've got our canvas initialization. So this is a bunch of code that is not particularly exciting to dive into detail on, but this is the code that makes sure that everything is drawn at the appropriate aspect ratio and to size to the user's window. I will probably post an example of this on GitHub soon. I've released some of this code before in a generic format. One thing to note, I use two canvases when I'm drawing. The outermost one is like the parent canvas. This sees things like, for example, if I set a message, or if I set a detail level and I get a message here at the bottom, that's drawn on the parent canvas. The art itself is rendered into a secondary canvas that's then drawn onto the first canvas. And so I call the outer canvas the container, and I call the inner canvas the scene. So this sets up those two canvases. Now, I use the buffering for performance benefits, but beyond that, I'll talk more in detail later about other things I can use that second canvas for in terms of transparency effects and filters. This just boots up the animation when the content loads. Here's a great scaffolding example. Let's skip ahead to the code and then I'll come back to this. So this block of code right here, based on how blurry the animation is, like whether it's, got a lot of transparency effects or it's very clean, I draw different, I use different filters. So I'm using the global composite operation filters that are just part of JavaScript to apply like saturation effects, color dodge, multiply, lightning, that sort of thing. But one thing I noticed when I was experimenting with these is they don't all work for every scenario. Like some of the transparency levels, only certain effects work. So this is one of a number of cases I've run into where it's not necessarily clear like what the right answer is. It's sort of subjective, like what saturation filter looks right with a blurry, animation. What, color dodge looks right with a really crisp animation. It's not totally clear. So, I'll get into where these variables are used in a little bit, but what this code does is it's deciding, in some cases based on other variables, like which filters to apply. Like, if you're not, doing a color dodge, then you can do a lighten for the blurry one, for example. But how did I make sure that I had the right things in here? I tried a bunch of them, right? So I would kind of hard code set my blur level to a particular one, and then I would try different combinations of filters, and I would try it on like 10 or 20 or however many random outputs and see like, does it look great all the time? Does it look great none of the time? Does it look great, sometimes? And based on that, I came up with this logic to draw the filters. So the code that was used to initially figure that out is not here anymore. Some information about it is here anymore. In a lot of cases, not even this remains, only the code is left. So only the destinations in the code and not how I got to it for a few things like the automaton and the colors. Got a main draw loop here. One of the main improvements I made over previous animations I've done is I added sort of real-time performance monitoring. So I take a look at, as each frame is drawn, if I want to draw 10 frames a second and I'm only hitting 9 frames a second, then, I need to draw the next frame a little faster. And if I'm drawing too many frames, I need to draw the next frame a little slower, which is pretty helpful in terms of like, I wonder 5 or 10 years from now when computers are a lot faster without this, like, I suspect that, projects that don't have this might, run at like 200 frames a second, like we see with, say, Unreal Tournament or other old games running on modern hardware. So that helps keep the animation smooth. I also use this to control the frame rate, set it down to 1, set it up again, whatever the case may be. Just tracking how many frames have elapsed, use that for quite a few things. One thing I use to get a little bit more diversity, in a lot of cases, I rotate the animation. So sometimes it'll be rotated 90 degrees, flipped upside down. this is where I get into actually using the filters, which is probably a little more interesting than the logic used to draw them. I've got this function that just, it takes the buffer canvas, so that's the actual animation, like the cellular automata that I've been drawing, and it takes that, what's on that canvas, and it stretches it onto the outer canvas and draws it. So depending on whether you're using perfect pixel mode or not, that'll either be, to the size of your screen, or to the right size to match your pixels. So the first thing you do is just draw it onto the screen, which is great. But I noticed in a lot of cases I wasn't loving the colors that I was getting, and so I wanted to use some filters to kind of tune that up. I'm going to turn off this particular. Well, actually, I'll keep the seed on, but I want to go back to the sketch real quick and undo this change to add blocks, resolution. Head back up to the top there. Cool. So we've got our animation going. And I think I'll got a few cool animations in here. Try and pick one that's a little more interesting color-wise. That one, let's try this one. Yeah, this will do. It's a little on the let's try. This one. Yeah, I think this will work. So if I turn off all of these other filters, delete this unneeded code for now. See what it looks like without any of the filters. In this case, not super exciting. Let me see, what line am I on here? 568. I'm going to set the blur to be on. So that should give us a better idea of what some of the colors look like. Yeah, so the colors here look kind of muted, especially with it blurred. Let's see if we jump back down and re-enable this filters, if it looks any better with the seed locked in. Like, see how this is just kind of muddy and dark? Hopefully for this one, we'll get some better colors with our filters enabled. Yeah, it looks better. That's brighter. Part of the trick to using these filters I found is, sometimes like a color dodge or multiply, but particularly color dodge will be a little extreme. So, one thing you can do before using it is, set your alpha level pretty low. So like for this filter, well, to take a step back, I probably mentioned this, but in each of these, I'm drawing canvas 2 onto canvas 1. So by setting the global alpha for context, or canvas 1 to be 0.2, when I call this draw function and draw, my main animation canvas onto the container, it just draws like a transparent one. So it's just doing a little bit of a color dodge there. Tricky thing about this, like a lot of features that required that scaffolding approach, is it doesn't always cause an issue, right? So even if I disable these filters, imagine if I load up a number of outputs, a lot of them will pretty much be acceptable. Only occasionally, like this one's fairly dark. Maybe these filters are more helpful than I remember. Any old way. Those are the filters. This is a feature I like. So let's see here. I'm going to disable all of the drawing entirely. blow this up a bit. Make sure I don't have a bug here. You might not see it all the time. What I'm aiming to show is there's a static texture. There we go. Stop the blur turned on. There's a static texture that is drawn over top of everything in an attempt to add a bit of warmth. Let's try full screen. There it is. It's very subtle. I'm not sure if you'll even be able to see it on the stream, but take a look when you look at the live animation. What's happening here, there's a bunch of random, very small lines and squares that are being drawn that are fairly transparent with each frame on the container canvas. So like this is drawn on top of the actual animation in each frame and just gives it more like a warm, like staticky television vibe. Like you're looking at a CRT or something, which I enjoyed. I don't like it if it's too clean. So yeah, there's just a bunch of randomization and drawing some lines in there. Got some logic in here to draw, like this is the messaging engine that sits at the bottom of the screen. It draws a rectangle on the outermost canvas. And then we've got our draw loop here. What else do we have in here? Like I mentioned, a bunch of handlers, so you can update the frame rate, you can update the aspect ratio, go full screen, a number of other controls. This code may be of a little more interest. So this is the code that actually opens the menu. So when I press H and bring it up, I showed the HTML content for the menu before, but this is the actual code that puts the menu into the DOM. Really not that bad, honestly. Like once you have it, it's been no touch after Zoologic for this project, which has been great. Keyboard interactivity handling. I just put this on a listener on the document when it mounts up. And then very important functions here, canvas blanking. So after each frame, I draw a black rectangle over the entire screen. When I want to totally erase what's on the screen, I draw a totally black rectangle, and then I draw the animation in, with full color and no transparency. When I want some sort of a blur effect, like I mentioned a little earlier on, I'll draw like a transparent black rectangle. If you don't do that at all, then eventually you get so many colors stacked on top of each other that it just starts to look like a mess. So you kind of need to clear it a little over time. One thing I noticed while I'm here talking about this, well, first off, here you can see where that super dreamy variable I talked about earlier comes into play. We use a different alpha transparency for drawing that black rectangle. It's not as opaque, which makes things look a little dreamier. But let's see. I don't remember what else I had to say about that particular note, but that's okay. We'll come back to it. So I'm about to move on to the core algorithm and talk about like how that's actually drawn. Just want to hit a few high points that I would say keep an eye out for these and where they come into play, because they're fairly important. I've written more about these on my blog if you want to read in more detail. One thing I learned is you can parallelize things with worker threads, which I'll show. So you can use multiple cores of a CPU. I haven't made the leap to WebGL and using GPUs yet to do things in parallel. So for me, I found this was a pretty helpful technique. I got double-digit performance improvements from using it. Memoization, really important. When you have important calculations you need to do every frame, storing those really helps performance. Like for example, calculating where these circles are and their size and their boundaries in each frame involves trig functions like sine and cosine, and determining if a pixel is inside of it, that sort of thing. So you don't want to calculate that on every frame. It's good to remember it. Let's see. Yeah, I mentioned this before. Tuning your draw loop based on the actual rendering time helps things look a lot smoother. I use the XOR operation a ton in this project. It's a very fast operation, and it drives like all the overlapping of shapes. It's a very helpful technique for when you have multiple shapes overlapping and you want to like cut out their overlapped section. I mentioned scaffolding, like adding additional code to the app that doesn't make it into the final product along the way. And I mentioned the filtering and layering with global composite operation, which this is my first time using it. I thought it was really helpful to fine tune the appearance of the output the way I wanted. So without further ado, I will dive into the actual animation itself. This is a very long file. I think it's 3,000 lines long. So you're going to get the Cliff Notes version here. So going through the algorithm, I'm going to do these in parallel. So over here on the right, the first main section, as in a lot of generative art projects, I assume, is setting up the variables for the particular output. So the first thing I do, which I guess is a stylistic choice, I like to choose a preset. Like I like to have some main categories that my outputs fall into that I kind of work within. So here are the animation preset feature that you'll see on implications, complete with their working titles like Quad Spiral, or the Quixote one used to be called Windmill. Magic 8 Ball's always been that. A little factoid about the double hourglass preset. It's really just an hourglass. At this point, there's just a 30% chance that a hourglass will turn into a double hourglass. And the double hourglass was actually just like a happy accident that happened while I was making an hourglass. So they're closely related. Got my list of presets. I pick one. So of those presets, the anything preset here, which is also known as Imagine, which is like the most unbounded one where really kind of anything can happen, there's a 10% chance that that comes up just on any given output. The rest of them have even chances, but with the caveat that the last one here, which is referred to as implications in the actual launch, these are the ones with sliders and only sliders. There are 2 of these. So they're slightly more common because there are a ton of different possible slider outputs that can come out. Next, I select some default values for core variables and values. So, my esoterically named doing a slider thing, where I decide, is this animation going to have sliders in it or not? So like I mentioned, the implications preset here, it's called new batch. It always includes sliders. Otherwise, it's a 50-50 chance by default. What type of circles will be in the animation? So the way that this whole project started, and it's very small, but you might see it here in the upper left. It was called Cultural Exchange. It was a sketch where I had I wanted to see what happened when 2 automata interacted within a shared space. And so I had these circles that would like just grow and shrink, and they'd like overlap, and then they'd come back together, and they look like petri dishes with stuff in them. I was like, oh, they look like cultures in a lab, like exchanging information. So I called it Cultural Exchange, just as a working title. But because of its origin, in circles, the circles play a very central role, and each animation has one of 3 kinds of circles at its core. There are some that have only a single large circle in the middle. And actually, I'm going to go ahead and start playing around with some of these things. So if I say 0 for the circle type, this is where the presets come into play. So I'm going to go ahead and I'm going to say anything goes because the presets are going to override my variables. And so here's an example of a single circle output. You can see it's got a single circle in the middle. There's a triangle, there's some sliders, but at its core, there is a single circle. There are some that have 3 circles. Number 2. So like this one is a stack of 3 circles. Sometimes it takes a moment for the circles to appear. That one might take a while. This one, 3 circles. And then you've also got cases where there are 4 circles. And this one, it's very difficult to see because there are a lot of sliders. Same for that one. Here you can see the 4 circles. So that's the circle type. I'll leave that on 0 preset for now. Cyber circles. So one concept that I don't think has ever really made it public, but I use a lot internally on this project is the idea of 2 kinds of automata. So there's one special one that's called creep that you can kind of see here in the blue. It's the one that looks like surface tension or like a fluid. And then all the other automata I called cyber because they look a little more cybernetic to me. They look kind of artificial. So this variable determines like which of those 2, like the creep or the cyber, appears inside of the circles initially. So some animations, the outside will be like a circuit board. Sometimes it'll be like clouds. And it depends on that. The Zor circles property here, another hidden trait. You see how these circles overlap in the middle? Oh, well, I changed the code, so we can watch these. So yeah, on this one, you can see where the circles overlap. There's a cutout here. These circles are like cutting each other out. They're using the XOR function to make that cut. On the last animation, which you can just say false, and we can see the same thing. That's a weird output. Give me a nice one. Well, the long and short of it is that sometimes when the circles overlap, they don't cut each other out. They just look like 3 circles stacked on top of each other. Or however many circles. The Zor circle toggle variable is kind of interesting. It makes it so that when, in some cases, when the circles reach their minimum extent and they start to expand again, they switch behaviors. They switch this Zor circle behavior. So keep an eye out for that. Centered circles and flip centered circles. These are specific to the 3 circle case. These determine, well, let me just go ahead and turn that on again. 3 circles. So this is a case where the circles are not centered. So they're along a diagonal line. If they were centered, they'd be along a vertical line. Flip center determines whether they angle, top left to bottom right or the other way. And then, like I mentioned before, there's rotation. So these could just be arbitrarily rotated depending on the output, but keeps them from all like looking exactly the same. So get rid of that circle display type before I forget. We've got some variables here. If they're at an angle, you can determine how far off center they are, like what's the angle of the line that the circles are on. There's some hidden variables for how fast the circles expand or contract. Here, starting on line 75, we've got some variables related to the canvas topology and symmetry. So, the edges of the canvas can connect or they cannot connect. It can either be treated like a box, or if it's like toroidal, it's actually like it's being rendered on the surface of a donut, which is kind of interesting to think about. Symmetry, I choose I choose a type of symmetry based on what kind of circles I'm using, because only certain types of symmetry will be possible. Like it's hard to think of an example here, but I'm gonna jump to features file real quick for my circle descriptions, which will help describe what these 7 different symmetries are. Which will make more sense. I think it's SimDesk. Yeah. So some of the sort of symmetries that variable was talking about, double reflection or four-way mirror, where the top and bottom of the animation are a reflection of each other, and the left and right are also a reflection. Arbitrary means there's no symmetry at all. It can be reflected across a diagonal axis. It can have rotational reflection, where it sort of seems to be spiraling around a center point. Repetition, don't worry about, that gets replaced at some point. It can be left-right mirrored. It can be top-bottom mirrored. Lots of different kinds of mirroring that can happen. So if I go back to my animation, we choose one of those kinds of symmetry that's applicable for the kind of circles we have. We've got some more code here that determines if we want to wipe, if we want to truly wipe the canvas after each frame or not. And then the alpha will determine what that looks like. Reality filter is, I don't know, I couldn't think of a better name for it. What reality filter is on every frame, you know, I've got this scene of automata that I'm drawing, like these shapes, these pixels, like I've got a grid of pixels that all need to be drawn. In theory, they've got some sort of symmetry. Well, the question is sort of like, okay, if I've got something drawn with some sort of symmetry, what happens if I only render some of the pixels and I render them asymmetrically? Like if I provide an imperfect view of something that's sort of perfect to look at. So this has some pretty particular limitations on it, but I'm going to go ahead and try turning it on. It doesn't always look good with every possible combination. And it's also not Boolean. It should be. So yeah, here you can see 0.8. It's a little harder to see because of the large squares. And so I know I have some code further down that sometimes sets the reality filter more particularly when needed. But the long and short of it is, if you see, here's a good one. So if you see one that has this sort of staticky effect, it's because on each frame, a random selection of the pixels are being rendered. And if it's like 99% of them, it'll look pretty clear. If it's 30% of them, you'll get something that looks very staticky and distorted, which I find pretty interesting to look at. Detail level. So this detail index, I determine which of the detail levels, like, you know, on the large side, Blancs, on the small side, Pico, I want to use. Yeah, there's only like a 1 in 2,000 chance of defaulting to a Blancs output. So like the couple of bottom display levels, I wanted them to be essentially impossible to come up, and I don't think any Blancs did come up in the mint, which is what I wanted. But I kind of wanted there to be like this random, like tiny little chance that it might happen. So these are only accessible detail level controls I'm using here on the animation. We're going to do this hour pretty quick. I'd better make some good time, huh? So let's see, shape, type, and behavior for the circles and squares. For one, not all animations have to have triangles or squares. Some of them can be rendered without shapes at all, just circles or sliders. Sometimes the shapes are squares, sometimes they're triangles. If you've got certain kinds of symmetry, you need squares because you can't attain those symmetries at all with triangles. There's more logic for this later. I will just say you'll probably see a number of places in the code, or just know that it's there, where I make a lot of complicated decisions about how to rotate, like say these squares that we're looking at here. Like, I think this is just a totally, yeah, it is. It's a totally asymmetrical output. But you have to be very intentional about your choice of rotations for the shapes for them to maintain symmetry. Otherwise, as you see here, you get something that's totally asymmetrical. So I'm going to go ahead and I guess I'll turn on, I don't know, circle stack 1 for a moment. Yeah. I'll just leave it for a second. But suffice to say that certain, those presets that depend on like a particular arrangement of the shapes, like this one, for example, this one has rotational symmetry over here on the right. Blow it up a little bit. Like if these squares were not rotated just so at the start, like if one of them was sort of like off kilter, then that wouldn't work. And same with triangles, but they're even more particular. Let's see. We've got some default settings for like triangle radius, whether the triangle is being drawn on a centered circle or needs to be drawn, on the 3 or 4 circles. Growth steps and rotation steps. So for each of these triangles, it has a fixed number of rotational positions and growth positions. The reason it's a fixed number is because I need to know the exact spots the corners of the triangle or square or whatever shape can be in, so that I can memorize that. I actually remember all the possible points that the corners of the triangle can be in, and then just look those up later based on how much time has passed. So I don't need to use sine and cosine again once the animation is running. So here we choose a starting seed and state. So which seed, which cells are alive or dead in the cellular automaton to start off. Every cell starts in a state of either alive or dead. Looking for where this is used. Just wanted to skip ahead to that real quick. We'll come back here. No, I've gone too far. Here we go. So this is the section where the seeds are actually used, way further down. Not quite that far down. Here we go. Bear with me. Like I said, some of my variable names in here aren't the most intuitive. This is a section of the code that's looping over the X and Y coordinates for the grid and determining the initial placement of cells. I think there are 19 different possible starting configurations that cells can be put in. So each of these cases is a different configuration. They use a number of variables that are set randomly above. And each of them has sort of a generative aspect to it where they're not exactly the same every time. Some of them use trig. Some of them, like this one, it just draws a cross on the screen. Some of them will draw like a lotus. This one in particular that we just saw, if I resize it, uses an elementary cellular automata at the start there in the background before it fades away. But let me jump back up to where I was starting here. Automata definition. All right, so I'm going to run through this algorithm real quick, just to leave some time for questions, and then I can always do a deeper dive on some of this stuff later. But all these variables up at the top of the animation have been set to some somewhat sane, reasonable value. Now, like, all those values need to be tuned based on which preset this is. Like if it's an hourglass animation, or if it's an implications animation, or whichever kaleidoscope, whichever kind it is. So you'll see these cases like, oh, if it's a circle stack 2, or hourglass, it needs to have 3 circles, and the circles need to be centered, and the triangles need to be of a certain size, and these sorts of things that if you read through them, you would sort of recognize the individual output. But there's a lot of nuance and detail. Like I would kind of hard code each preset and then sit down and spend a lot of time fine tuning the variables until I was happy with, for example, how an hourglass looks, or how a kaleidoscope looks, how a magic 8-ball looks. Let's see. So a lot of code in here to set things based on the preset. You can see, we're 600 lines in there. We have to select some presets for sliders. It works very similar, where there's some sort of hard-coded different kinds of sliders. The sliders also have a symmetry, which you may have noticed. Like they can preserve a rotational symmetry, or they can be, mirrored left to right. A big challenge for this project was making sure that like the shapes that are rendered and the sliders that are rendered and the automata starting configuration for textures that are rendered, like figuring out what the sort of emergent symmetry is for all those things. Like if you have a 4-way symmetry where the top and bottom and left and right mirror each other, but your background is like a diagonal line, then it's not going to preserve that symmetry overall. So I had to give a lot of thought to how these symmetries for the different aspects play together. Switching over here on the right to just the algorithm, we select the presets related to the sliders. I select a couple of color palettes for each output. Skipping past some of this stuff. I select a pixel style. So are the pixels going to be small, large? I'm sure you've seen the smaller, large pixels. You can look at the feature list, but normal pixels are just sort of a square that fills its space. Small ones leave a space between them with the grid. Large ones overlap each other. So I choose a pixel size. I have a large block of code that can go adjust a lot of these settings I've been talking about if the detail level changes. Because it matters if you have an odd or even number of pixels if you're trying to maintain symmetry. So sometimes you've got to go change some things up. Here I've got some code that I choose an automata that I'm going to use for this particular output. Which cellular automata I choose actually differs depending on whether they're tiny pixels or large pixels, or what sort of pixels there are, and also depending on like the level of blur. So like, for example, the very chaotic cellular automata that look a lot like static. If you've got a high level of blur, that looks really bad. It just looks like a blurry screen. So like those two can't go together. So I make some choices about which textures to choose based on a couple of those factors. Some of the automata also just don't look good with overlapping squares or with gaps between them. I already talked about the circles and triangles and so on. Okay, initializing the animation, I set up the grid that tracks the automata. I fill them in with the starting seed, like I mentioned. Well, actually, that's a little further down. I set the circles' positions on the screen, like where they are going to start out, what size they are. I go ahead and instantiate the shapes for the triangles, those sorts of things. Because earlier on, I've really just determined like what kind of circles will I have. What kind of triangles will I have? Will they be big? Will they be small? That sort of thing. But the actual calculation of their positions and sizes and things happens at the start of the animation. And just to show, like when I'm talking about initializing the animation, what I mean is if I go over here, I should have, here's my default sketch I start with my little framework. And here there's a function called init animation that just sets up your animation. There's an update animation state that makes changes to the animation state between each frame. And then there's a function that actually draws the state onto the screen. And these things are handled automatically by that core library. You just put whatever you want in these functions and away it goes. Heading back over to the animation. Let's see here. So we do the automata selection. We set up the shapes. We have to prepare the sliders. So similar to the shapes, we decide where the sliders, the little sliding rectangles that go across the screen are going to go. To preserve symmetry with those, like if I've got a slider that's going like across the screen on the top and I want to have a rotational symmetry, then I need another slider that's going to go across on the bottom. So I've got a block of code that sort of mirrors the sliders and adds additional ones to preserve that symmetry. And then, yeah, at the update animation, at the very end of this function, I calculate some functions that determine how to draw each individual square onto the screen for the parameters of the animation, so that I don't have to calculate some of these things again. So I guess I'll have to cover this quick. Might start, if people want to start popping some questions in there about what you've seen so far, go ahead and do it. I may have to do a follow-up or part 2 at some point to talk more about what happens during each frame. But in a nutshell, what happens during each frame is I adjust the colors. If you watch, you'll see the colors gradually change over time. How that works, I change. Hey, here's someone else on there. No.
Hey, we have a couple of questions if you want me to jump into it right now. But if you wanted to finish this this topic too, I'm happy to wait. Whatever you prefer.
Cool. Is it all right if we run a few minutes over?
Yeah, no problem.
Cool. I'll sweep through this real quick and then I'll take a couple questions.
Cool. Sounds good.
So we adjust the colors in each frame as the animation evolves. We determine the exact positioning of the circles over time. Like you'll see that the circles kind of grow and shrink, and then the shapes also rotate. So we need to determine, what state are the circles in currently, what state are the sweepers in, what state are the sliders in, like the vertical or horizontal bars that go across the screen. This is where the worker threads come in. So if I pop over to my update animation state, the workers are basically a separate thread that you can post a message to. So you can put a bunch of data into them. You can get a bunch of data out of them, but they can't actually access variables outside other than what they get in the message. So for like changing the colors, I pass in all the information I have about the current colors, and then it gives me back information about what the color should be in the next frame. I pass into this worker a bunch of information about what the current state is of the circles, and I get information back from the thread about what the next state of the circle should be. And then similarly for the sliders and the sweepers. And then I've got this line here that basically says, wait for all of these things to resolve. So calculating the colors, the circles, and the sliders next move is all happening in parallel on different cores of your processor, which I think gave me like a 20% plus speed up when I implemented it, which was pretty exciting. So now that you know where all the things actually are and what color they're supposed to be, you need to check each pixel and see, is it in a circle? Is it in a triangle? Is it, for each of these, what shapes is it in? And then use that XOR function to say, oh, like if it's out here, it's in the outside. But if it's inside the circle, I need to flip it to inside. But then if it's inside of 2 shapes, I flip it again. And then you see the sweeper going down. If it's inside 4 shapes, then like flip it again. So it's just a reverse every time a shape overlaps. So we figure out, which of the 2 color and equation combinations we're working with. And then we know how to calculate the next state of that automaton. We count the cell's neighbors. We look at the cell's neighbors. So each cell has 8 cells around it, and each of those cells have 8 cells around them. So you look at actually like the second nearest neighbor, like the 72 cells around, and based on that, you choose a color. So a little short on time, but you can basically take a color palette and spread it across 72 slots, and then pick one of those slots based on the neighbor count, and that determines your color. Based on what color the cell is, I throw the coordinates for the cell into a bucket. So like all the white cells go into a bucket, all the pink cells go into a bucket, etc. So that when I'm drawing them later on, I don't need to set the color between each cell, which is very expensive. I just say, set the color to white, now draw the white cells, set the color to green, draw the green cells. So it's actually independently drawing the cells of each color in each frame as a performance improvement. I've got what's called boringness detection here, where if it detects too many of the cells have died, or there are cells overrunning the canvas and no free space, or nothing is changing, it's just a static dead animation, and then it'll go ahead and cycle the equations being used and switch to a new one. That's pretty much it for updating the animation. Really all that's left at the very bottom, the render function, it's almost nothing. It's just, blanking out the canvas, drawing the background pixels. So like the green here would be considered the background, and then drawing the foreground pixels, which are the ones in the shape here. And that's your main draw. So that's a whirlwind tour of this algorithm. You said there are some questions, Pompey?
Yes, sir. First, thank you for going to that deep dive. I think, as a viewer, you could tell there's a lot going on just from, watching the animation, and then seeing you line up all this code and go through it. There's so much more to it than one can even imagine, and cover in an hour, obviously. I kind of want to start with this question. So, coming from Zoologic to this, and the time that you spent here, going through it, there's so many ideas that you included, so many different traits, characteristics. How did you go about like planning and mapping before you even began coding, or was it you began coding and then it kind of just developed into what it is?
Yeah, it's a great question. My style of coding, like my background in making math art has been as a hobbyist doing sketches for however many years, like 15 years. So I kind of, in my past, was in a habit of just sort of doing whatever came to mind, just getting the ideas onto the screen, saying, oh, that's cool, like, but what if this? And then I chase it. Well, with Zoologic, I did that to the extreme. Basically, stream of consciousness for like 2 months. Like, oh, like what else can I jam in there that'll be cool to play with? And it was a little bit too much, I would say, in my opinion. Now it was a little bit too jam packed. There was a little bit too much in there. So I was definitely conscious of that when building implications, to try to not make it too complex on the surface, like the part that people are seeing, because I don't think that it improves people's appreciation of what's going on. And I felt like it was a good exercise for me to be a little more intentional about what I wanted to do. So with this one, I very much started with like a core concept, which is actually a question asked by Math A, the artist on Art Blocks. They had asked about my first project, Mono no Aware, um, do you use more than one automaton in there at a time? And I was like, no, but that would be interesting. And so this sketch was exploring that, and that's what it eventually became implications. It was, how can I divide the canvas into two regions with different automaton and see how they interact? And so I really tried to focus on that and make that the main like draw or intrigue of the piece. And then I tried to strip away a lot of like the interactivity I had with Zoologic and make it a little more streamlined and just like something you don't have to think about as much as just look at.
And then I think I always ask every artist this question because I think the refining process is, can be the hardest part. So specifically here with implications, how did you know when to stop including, additional traits and pushing the limit of the algorithm?
Well, I'd say I erred on the side of caution because I was very sensitive about, in a good way, in a constructive way, about feedback I'd gotten about Zoologic to not shove too much in there. So I erred on the simpler side. I had, a handful of presets. When I initially uploaded this script to the testnet, thinking, okay, like I feel like this is kind of done. Like I feel like this is good. I kind of sat with it for a week or two, and I was like, it's not good enough for me. Like it's not engaging enough. At that point in the animation, I didn't have the small or large pixels. I didn't have any sliders. I didn't have any filters, I don't think. I didn't have a lot of the things that really pulled together to make this what it was. So I feel like there was a mix of, when I hit that first finish line, I felt like, I'm satisfied with what I've made, and I'm satisfied that I haven't shoved too much into it. And then the second sort of finish line, which it took another month and a half after that to get to where I eventually landed, was, when do the things that I have look good, like every time they come up? Like, when do I feel like there are no outputs? Like if I bring up, 1,000 outputs that I see like one or less that I don't care for. So that was kind of the mark I was aiming for. It was very subjective, I think.
Cool. We have a question from Tiska Tech Reviews. They ask, do you have plans of a crossover between your three collections, or will they remain distinct from each other?
That's a good question. So I don't know that there's going to be like I'll say this. I think from like a, say, utility perspective, there will definitely not be a crossover that involves these things. From a idea exchange perspective, I would say this project is very much a spiritual successor to Mona no Aware, my first Art Blocks project. Mona no Aware was released about a month after I started on the sketch for implications. So this was, I think, September of 2021. I started on the sketch for this. So there's a lot of connection there. But then also it was built on top of a lot of the code I used for Zoologic because I really wanted to make a framework. So it had a lot in common there. I've been thinking a lot about sketches. Like it's quite possible that I will at some point in the future bring back the idea of, say, like evolutionary algorithms or small creatures that move around that are like an automaton with a lot of state in each cell that's like making some very complex decisions, as opposed to this one that's very simple. Might not do it on a hexagonal grid, but I feel like, the concepts of symmetry, the sort of pixel art style that Implications has, and just sort of that biologic influence of Zoologic, they're all candidates for future work.
And I have one more question from the audience, Nick. And this is up to you to share as much or as little as you want, of course. They asked, what type of applications do you code in your day job?
So in my current day job for like the last 5 years or so, I've been doing front end web development. So I do web development at a large education company. So, um, like I guess I'd say millions of users at peak at our site. So a lot of like performance tuning, a lot of like high reliability front end development. Um, so I've been able to bring a lot of my JavaScript experience the past 5 years there over to art. My background is mostly in like back end software engineering. If that answers the question.
Yeah, and there's one other thing he says. There's one comment that I wanted to highlight that I love to see this. He said, "I see your code as the brush very clearly now," and that's like kind of like the whole point of all these episodes as well, is to just provide more insight into these the project, because it really, especially with you running outputs live, like as you're tweaking the code, it really shows what turning a couple of dials can do. So I appreciate you taking the time and prepping this, and doing a full hour presentation. And I want to thank everyone who watched live today and will be watching in the future, of course. And anything else you wanted to close with, Ixnay?
Well, I want to say thanks to everyone for tuning in, and thank you, Pompey, for hosting. Thanks for helping me, get the stream set up, all that sort of stuff. Yeah, there's a lot more about this application I could talk about. I'm sure that's true of a lot of generative art projects, but in particular, like how the automata are chosen, like how they were picked from a set of 250,000, and how the colors were selected, which was very, how to say it, very improvised. I like to say the project's very irreverent about color. I think those are both pretty interesting topics I didn't really get to touch on much. So if you're interested, reach out or check out my blog. There's some more info in there about it.
Awesome. Thank you again, Ixnay, and for everyone watching, till next time, and happy minting.
Thank you. Take care.
See y'all.